Hello people, this is Exoplanetary Guides number 4. Today we're going to be assessing the TRAPPIST-1 system. It's been in the news a bit recently because NASA discovered 7 planets orbiting around it. That is a lot of planets. And they're all rocky as well, so yeah, let's get stuck in. Now the main star of this system, TRAPPIST-1, is an ultra-cool dwarf star, which means it isn't very hot. It's actually very well, I mean, I wouldn't say cold. 3,000 degrees Kelvin isn't very cold compared to some things you see in the house, but it's very cold when you compare it to some of the larger stars. And because of that temperature, it's got not that high of a luminescence as well. It's only got a mass of 83.8 Jupiters, which sounds like a lot, but when it comes to stars, that's very small. Hence the name ultra-cool dwarf star. It's located 39 light years away in the constellation Aquarius, which I have on good authority is the best constellation. In 2015, Belgian scientists at the University of Liège, pretty standard that, detected 3 planets around the star, which would be B, C, and D. They managed to find them using transit photometry, which basically you look at the star and you observe its brightness over the course of, I don't know, maybe a few years. And sometimes you might see occasional dips in the brightness. Now this is due to a transit of a planet. This isn't possible for all stars, but for some stars, especially closer stars, it is very possible. And they discovered the 3 planets like this in 2015. And just a few days ago now, or 2 days ago today, it was announced that 4 more exoplanets were discovered. And at least 3, if not all, are in the habitable zone. And if that ain't pretty cool, I don't know what is. Now there's a few planets that we need to get through, so we'll try and rush right through them. The first one here, TRAPPIST-1b. It's quite small, and even though it does say on the NASA website that all of these planets could potentially be in the habitable zone, according to Universe Sandbox, this one definitely isn't. Look at the surface temperature there, 183 degrees C, which is a bit too high for water. It's been looked at using spectral analysis, and it's been seen that it's got a cloudless hydrogen atmosphere, so there's probably nothing going on there in terms of life, unfortunately. Now, most of what I've said about TRAPPIST-B also applies to TRAPPIST-C, so we're just going to skip over that one and move straight on to the D. It's got a mass of almost 2 times the Earth, and if you have a look at it, which I'm sure you will have noticed, it is covered in water. Surface temperature of 24.7 degrees. Oh, toasty. Now this planet is very promising. It's the only one on Universe Sandbox that actually looks like it could host liquid water. TRAPPIST-E does look like it might be able to, given the right circumstances, but this is a real interesting discovery. And if we can have a look at the atmosphere, see if there's any weird methane or stuff being pumped out, we might be able to see whether this is a lovely environment for life, or it's just a rock, because it could always just be a rock. Now, I may have made a little mistake when it comes to TRAPPIST-1e. When I initially set up this simulation, according to Universe Sandbox, this planet had a surface temperature of negative 20 degrees Celsius, which is obviously a bit too low for liquid water. And I didn't just want to have the one planet with water on it, I wanted to emphasize the fact that this discovery was of a whole system that could be considered potentially habitable. So I wanted to have this one with water as well. So I decided to try and figure out a way how to up the temperature. Now I could do this in 2 ways really. I could lower the orbital distance, as in make it closer to the star, or I could increase the greenhouse effect. And I decided to do the latter. And it went a bit wrong in terms of the fact I made the planet essentially into Venus. So it's a bit too hot now, but if you could do me a favour and just imagine this whole planet is blue with lush forests and oceans teeming with life, that would be brilliant. A lot of what I said about D also applies to this, in the same way that a lot I said about B also applies to C. Now, the other 3 planets in the system are just cold rocks, according to this simulation, so there's no point looking at them, but what you have to get in your mind is these planets are absolutely amazing in terms of being 7 planets so close in terms of orbit to the star. It's just amazing. So that's me finished on the actual planets, and now let's go to assessing the habitability of the entire system as a whole. Now, as you could maybe tell from my moderately clickbaity title, there is something we need to talk about. Now, TRAPPIST-1, obviously a lot of media attention, but if you actually look at the system itself, there are more promising places that I've seen in terms of potential life outside of our solar system. Now, the first thing we need to talk about is with these really small stars, planets tend to be a bit closer. So you've got your ball in the middle and your planet's really dotted close to the star. Now, stars like this have been shown to have a lot of solar activity in terms of solar flares and like huge plasma ejections from time to time, and they're not exactly brilliant when you're trying to build up sort of an ecosystem. So there's one thing that's a sort of negative. Also, a big one for me at least is the fact that all of these planets are tidally locked. Now, what this basically means is, in the same way that the moon is, all of the planets are facing the star as it orbits. This basically means one rotation is the same time as one orbit. So the same face of the planet is always facing the star. Now, what this would do to the planet is create one half that's searing hot and one other half that's very, very cold. There's actually an example in our solar system, Mercury. Even though it's the closest planet and you would consider it to be the hottest, it's actually not. Venus is the hottest, but Mercury is actually incredibly cold. And although it's not tidally locked per se, it's partially tidally locked. So for a long time in the year, bits of Mercury don't see the sun, and those bits get really, really cold despite being so close to the sun. Now, for life finds the way, but I can't see life forming on a tidally locked planet unless the region between the really hot side and the really cold side, which is often called the terminator zone, maybe life could spring up there, but that's the only problem I really have with this star system in terms of its habitability. A good thing about these stars, though, the really small stars, is they can live for a long time. And when I say a long time, I mean 4 to 5 trillion years. Now, even if we consider that it's tidally locked and solar flares might be irradiating the surface every couple of years, that is a lot of time for things to happen. And even if something is a 1 in a billion chance, when you've got 4 to 5 trillion years to keep rolling that dice, it's very possible that you will roll a lucky number 7. So overall, what would I give this planetary system out of 10 in terms of a rating of its habitability potential? I'd give it a solid 7. The fact that this star can live for 4 to 5 trillion years is just, you've got to consider that. Even the most unlikely things would happen. And life, it seems to spring up everywhere, so I wouldn't be averse for it to spring up here. Though we do need to take into account the tidally locked planets and the flares that it shoots out every now and again. But we've discussed that. And now, customary explosion to end the episode. Remember to like, subscribe, and I'll see you on the night.